Hey, what's up, GRE fans? Today what we're going to do is we're going to look at a quant problem, and let's go. Okay, so a committee of 5 is to be selected from amongst 5 boys and 6 girls. So already know that this is a selection problem, hence it's a combination problem, and we're not really interested in arranging anything. So let's just stop for a moment and just note it down. Okay, so we have 5 picks. I can choose 5 people. And amongst that, when I'm talking about the boys, there are 5, and the girls are 6. And if I combine them, the total will be 11. Okay, so far so good. In how many ways can this be done if the committee is to consist of at least 1 boy and at least 1 girl? So the given condition or the constraint is saying that, hey, you know what? At least 1 boy and at least 1 girl should be a member of the group. So why don't we just try some elements just to see what is going on? So I can come up with a group which says B, G, 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 okay? Total 5 picks. Or I can even reverse the order by saying, you know what? G, B, 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 and B. And I'm quickly realizing that, hey, you know what? This method is going to be very tedious. So I quickly shift my work approach to an inverse approach in which I'm like, hey, you know what? Why don't I combine the total combinations? I find the total combination and subtract to what I don't want. Don't want. So let's think about this. What are the things that we don't want? So at least 1 boy means that 1 or more boys. So what I don't want would be no boys, right? No boys. And when I'm thinking about the girls, 1 or more girl, what I don't want would be, okay, no girls, right? So now what I can do is find the total combination, find the total number of possible combination in which there are no boys, and then the total possible combination in which there are no girls, and subtract it from the total combination, and then we're going to get an answer. So if we look down, the analysis has been done just to save time. And what we're going to do is use this simple combination formula. And when we're talking about the total combinations, we have on the first spot, we have 11 possible choices, then 10, then 9, then 8, and then 7. And in the denominators, we're basically canceling the repeats. So if we solve this, we get 462. Now moving on to no boys allowed. So we have 5 picks. And starting from the 5 boys, then to 4, then to 3, then to 2, then to 1, and we want to remove the repeats, then we get 1. And starting from no girls, 6 girls, then 5, then 4, then 3, then 2, and eventually when we cancel the number of repeats, we get 6. So if we move up here, so there are total combination of 462 total combinations. No boys is just 1, and no girls is 6. And when we simplify this, we get 455. And if we move up here, answers are, oh yeah, the last one, option 5, or the last option is the answer.